In this lecture, we are going to get started building out our 3D roller project in Godot. So we're going to navigate to the Godot game engine. We are using version 4.3 for this project. We will choose a project name and a project path, and then press create. Here we're going to create a new 3D scene, and we can play and select the current scene as the main scene. Let's add a new child node to our node 3D, which is the default root in our game in this particular scene. I'm going to add an area 3D node, a region of 3D space that detects other collision objects when they enter. I'm going to add a child of a collision shape 3D. We must provide a shape for the collision shape in the inspector. Let's use a box shape. Then I'm going to add a CSG box as another child in my area 3D. You can also experiment with different sizes, but you don't want to change the area or the collision shape directly. Instead, you want to keep their scale uniform, and instead change the size of the shape resource. So I'm going to undo my sizing. You can undo any command with Command Z or Control Z. So what we can do is change the collision shape box shape, such as setting it to 100 on the Z axis, and you'll notice now you'll have this longer collision shape. The box itself you can also set to 100 on the Z axis to match, so we have this long platform. And you can choose a smaller, more manageable size for the debugging process, like 10 on the Z axis. So we have the node as the root, and let's add another child to our scene root. That will be a camera. You can then move around the camera, like move it back, move it up, and you can select the preview to see what the camera sees. In the inspector for the camera, under the node transform, you can change things like the position of the camera. You can also manually move the camera around. So let's just pick a centered spot. You can also preview the game by pressing play. Let's add another child node of a light. I'm going to choose directional light 3D as the type. And then we can move the light up in the scene and a bit centered. So this will bring some brightness to the scene. You can also rotate the light so it's pointing down in the direction, and that will allow the scene to be brighter, at least on the platform. You can also set the energy to be a larger value like 4, and this will increase the overall light in your scene. We have the node as the default root. We have the area for the platform, the camera, which we can move around to an ideal spot, and we have a light. So you can experiment with some positioning values that work for you. But for now, let's move on, and we can always do the fine-tuning of the scene later on. Join me in the next lecture to continue this project. In this lecture, we're going to add a rolling ball to represent the player in our 3D roller game. Let's add a new child node, this time of a type rigid body 3D, into our scene. We're going to attach a child of a collision shape 3D to the rigid body 3D. And we can see that we must add a shape to the collision shape. I'm going to add a sphere shape to represent the ball. I'm also going to add a CSG sphere 3D. And you can add that as a child of the collision shape. And this is going to draw the ball for our player. You can move around that sphere to start closer to the camera. And you'll notice that the default functionality will be the ball will fall straight through our platform. So what we can do is turn on collision for the sphere. So on the sphere object in the inspector. And we also have our platform. We can turn on collision for the platform box as well. If your platform has no rotation, then the sphere will not move when it drops onto the platform. If you add some rotation down here, some downward rotation on the platform, then the sphere will roll down the platform. You can choose if you want the movement of the sphere to be done with this gravity, or if you want the movement of the sphere to be done manually, like with code. You can push the sphere forward or apply velocity to it. You have these different options when working with the sphere. On our rigid body, we represent the sphere. It has a collision shape of a sphere and a CSG sphere. And you can adjust the position of your camera, your platform, and your sphere until you're happy with the view. We see that the sphere rolls down the platform and then falls off. There's this rolling effect now because we rotated the platform and we turned on collisions. You can move the position of your camera until you're at an optimal spot, like just behind the player there. And so the player starts to roll and then rolls off the platform. If you attach the camera to the player, then the camera is going to roll with the player. So we don't want to have the camera attached if we are going to have this rolling effect on the sphere. So in our inspector here, you can see all the different properties about your camera, and we can move the camera programmatically so that it follows the player. Because we see that if we attach the camera to the player in the hierarchy, then we see this rotation. Let's continue our project coming up next. Previously, we saw that attaching the camera to the player caused the camera to rotate. So we don't want to have the camera attached to the player. Instead, we want the camera to be a separate unit. Even if you lock the rotation here on the camera, it's still going to rotate. even if you, let's say, lock rotation on the player, well then you won't have any movement happening. So we can't lock the rotation on our player because we need that rolling to occur. So on my camera, I'm going to create a script to move the camera programmatically. I'm using the Cursor AI code editor as my code editor of choice here to move my camera. So in the process function, we want to move the camera forward. We can change the position of the camera directly through the position property. And then we want to make sure the camera is a direct child of the root of the scene. So we see that the camera can now move forward with some speed. And you can adjust that speed value if you want to slowly follow the player. If the player slows down or speeds up, then you'll have to adjust the camera's position as well to slow down or to speed up. Right now, the camera is just moving uniformly by direction times speed times a delta value. Let's continue this project coming up in the next lecture.